Hello students, this is Mr. Wilson. In this video I'm going to show you how to set up the block and tackle lab. Now a block and tackle looks kind of like this diagram over here. And a more familiar term you might have heard to describe a block and tackle is ropes and pulleys, right? These little wooden circles are pulleys and they are connected by ropes in a certain way. And because they're connected in a certain way, they allow you to do something very interesting. And that very interesting thing connects with the concept of work, which is what we are studying in physics now. So in this lab, you're going to assemble a block and tackle system. And by the end of the lab, I want you to be able to do a couple different things. First of all, I want you to be able to calculate the work done to lift a load. I want you to compare the work input to the work output of a block and tackle system. I want you to explain the benefit of using a block and tackle system to lift a load. So why did somebody somewhere in the ancient history of the human species invent a block and tackle? What's the purpose of having all this complicated arrangement of ropes and wooden circles? And then finally, and more abstractly, I want you to be able to connect the concepts of work and energy. Now, the equipment that you're going to need for this lab. First of all, you're going to need a physics stand, this white thing here, or it could be purple. And then you're going to need a ropes and pulleys set, which should come in a little baggie. Now, inside the ropes and pulleys set, you're going to find a couple different things. First of all, you're going to find a stationary block, which is attached to a movable block with red safety strings. Up here, this is the stationary block. This is the movable block. And these red strings here are safety strings. They actually have no impact on the function of the block and tackle system. They just make it so that it's easier to set the block and tackle system up. Now the first thing you're going to do is attach the stationary block to the physics stand using one of these black screw knobs, which should come in the baggie. And then you should also find some yellow string in the baggie. And the yellow string, I need you to unravel it completely. And I need you to take off the black pinch clips from the yellow string. Now, as soon as you get done with that, the bottom block is called the movable block. Now, the movable block needs to have a brass weight attached to the bottom of it. And you can screw the brass weight against the bottom of the block using a blue screw knob. Okay, we are kind of limited in number as far as how many of these brass weights we have. So try to get enough that your movable block hangs down taut. Now in this image here, I have set up my pulley system so that I have 6 strings supporting my movable block. 6 yellow strings here. The red strings, of course, don't count. And this yellow string, which is the one that you pull, also does not count because this does not actually support the load. This just allows you to lift the load. Now you are not going to start immediately by using all 6 strings to support the load. And if you use all 6 strings, that means that you're using all of the pulleys. You're not going to start out immediately doing that. At first, you're going to start using maybe 2 strings, or 3 strings, or 4 strings. It's up to you and your group. Now, there's a couple more things that you need for this lab. You are going to need a Labquest, which is this thing here. You're going to need a force sensor, which is this thingy right here. As soon as you get your force sensor, make sure to turn this switch over to the left so that it points at the plus or minus 10 newtons. And then you're also going to need measuring tape. Now, the Labquest, you should already know how to do this, but the first thing you need to do after you plug in the force sensor into the top of the Labquest, you need to zero it. You need to zero it. You can do that by taking your stylus, tapping on the screen here, and then tapping on 0. Now, as soon as you get your force sensor zeroed, you are going to measure the weight of the movable block and the brass weight. So notice in the image here, that I have my weight attached to the bottom of my movable block. Now you're going to attach the hook into the eyelet here in order to measure what the weight of this entire assembly is. And that number is going to go here. Now, I'm going to tell you to lift the load. This whole thing is the load. I'm going to tell you to lift it a set distance, 0.4 meters, which is, of course, the same thing as 40 centimeters. Now, here's a hint. You see over here, these holes on the side of the physics stand? Those holes are 5 centimeters apart. Use that fact to your advantage. Now, as soon as you know what the weight of the load is, and as soon as you know how far the load travels, then you know that you have a force and you have a distance. The force, of course, is just the weight. And the distance is the number that I tell you, 0.4 meters. That's how high up the load is going to go. When you have a force and you have a distance, and when your force points in the same direction as the distance, then you have work. You do work on the movable block and the brass weight when you apply a force on it through a distance. And the way to calculate work done on the movable block is force times distance. And that number is going to automatically pop out as joules. Put it right there. Now the bottom of that sheet of paper that I gave you should look like this. Now I want you to collect data for 3 different numbers of strings. So for example, you could have 2 strings, you could have 3 strings, and you can have 6 strings, or you can have 3 strings and 5 strings and 6 strings. I don't care. I do want you, at the very least, to have one trial in which you have 6 strings. Okay, that is a requirement. I want you to find a way to use all 6 strings to support the movable block. Now, in order to measure the force that is required to pull the string at a constant speed, here's what you're going to have to do. You've got your string that is kind of hanging out. Attach the force sensor to the string and tie it into a knot right there. And then you're going to pull on the string. You're going to pull on the string downward slowly, and you're going to try to pull on it at a constant speed. Now the way that you know that you're going at a constant speed is by looking at the graph on your force sensor. Okay? And remember, in order to get to the graph, you need to use your stylus and tap up on that tab right at the top. Now notice here that I'm losing my voice, good grief. Notice that the force rapidly increases and then it starts to level out as I was pulling on the string. This value right here is the average force that you apply. And if you use your stylus and tap right here, that should give you the value approximately of how much force you were applying to pull on the string. And it will show you the number right here. Now that number, that force, is going to go right here. And the force might be different depending on how many strings are supporting the block. Now the other thing that you're going to have to measure is how far do you have to pull the string in order to lift the movable block by 0.4 meters. How far do you have to pull this string in order to make the block go up by 0.4 meters? Now, as soon as you have a force and a distance, then you can find how much work you did to pull on the string.